Okay, so in this video we'll be looking at how you can answer questions in an exam setting. This comes from November 2021 past paper. So in this kind of situation, what I usually do is check first in the table what compounds are given for me, and if I'm only given the name or formula, I first draw so that I can see the structure. I understand better when I see the structure. So the same method can work for you also. So here, in the first compound A, you can see this is a carboxylic group. So I'm given a structure, and I have two carbons. So this is ethanoic acid. As simple as that. Since that is a carboxylic group. Okay, then in the second one, this is just a double bond, so it's an alkene. So let's check. Longest chain is 4 carbons, and we have a substituent at number 2, so this one will be a 2. Since it's only 1 carbon on the substituent, it's gonna be methyl. Then longest chain is 4 carbons, so the root will be but, and then the double bond is at number 2, so but 2 in. Okay, then here I'm given, on this one I'm given the molecular formula. I first draw the structure so I can see clearly. 2 carbons and 6 hydrogens. So let's see how I can figure out the structure. 3 hydrogens, so here I can put 2 hydrogens, so that makes 5, and I need to put 6. So that is where you realize that this will be an alcohol because of that oxygen. You are not gonna put only the hydrogen here because there's also oxygen, so that gives you a clue that this is an alcohol. So this one will be ethanol. Okay, and this one we're given the name, so let's draw the structure. But for 4 carbons, so 1 2 3 4, 2 on for ketone, so at number 2 we have double bond oxygen. Then 3 methyl, at number 3 we have a methyl substituent, which is 1 carbon. So that is the structure. So when you have the structures and the names, you will be able to flow when you have to answer the questions. Okay, and then on this one I have butanol, 4 carbons, null for carbonyl group for aldehydes. Yeah, this is an aldehyde, so double bond oxygen. But at number 3 I have a methyl, so let me put a methyl here. So CH3. Okay, I hope you get the idea now. So when we go to E, we have 2 carbons, 4 hydrogens, so that tells you we have a double bond here to complete the bonds. So this one is ethene, and then I'm going to draw structure C here. So C, we have how many carbons? 1 2 3 4 5. So 1 2 3 4 5. On the first carbon, 3 hydrogens. On the second carbon, 2 hydrogens. On the third one, I have 2 hydrogens. On the fourth one, no hydrogen, but I have an oxygen, so I'm gonna skip that one. On the last one, I have 3 hydrogens. So this carbon needs 2 bonds. That means I have double bond oxygen. So that one makes a ketone. So it's 5 carbons for pent. So it's gonna be pent 2 on. That is structure C. So now when it comes to answering the questions, you will just flow since you have now all the information. Okay, so now let's see the first question. That definition, I'll leave it up to you, and then write down the letter that represents an unsaturated compound. An unsaturated compound is a compound which has double bond or triple bonds between the carbons. So from this structure you can see compound E. Let's see what else we have. And also compound B. There is the double bond, compound B. So you can write E or B. The only one. So you can just write one of those. And then name the functional group of compound C. So compound C, let's go to the structure and see what we have. We're having a double bond oxygen on a carbon which is bonded to 2 other carbons. That means we have a ketone. So this is a ketone. Okay. It's not going to be an aldehyde. If it was an aldehyde, it would be in the first or last carbon. Okay. So write on the letter that represents the chain isomer of compound C. So chain isomer, it means the functional group is the same, the number of carbons the same, the molecular formula is the same, but they just change the chain. If you started with a long chain, now you have a short chain. Okay, so let's check which molecule has the same functional group as compound C and the same molecular formula as compound C, but different longer chain. In compound C, the longest chain is 5 carbons. That makes a pent. So let's see which one has a shorter chain, but still it's a ketone, and it still has the same molecular formula as compound C. Okay. 1, 2, 3, 4, 5. 2, 3. So let's check. Okay, I made a mistake by compound F. But 2 on. I didn't draw it correctly. I made the longest chain to be 5 carbons. So I need to fix that. Let me redraw compound F. So compound F, it's 4 carbons. At number 2, we have double bond oxygen. At number 3, we have a methyl group. H, K, C, H. So this is how it's supposed to look. The longest chain is 4 carbons. I made a mistake. Apologies for that. So let's see. So compound F will be the structure. It will be the chain isomer. It's still a ketone. Still same number of carbons. 1, 2, 3, 4, 5. Same as C. At C we have 1, 2, 3, 4, 5. Same number of hydrogens. You can count them. So the answer for 2.2.3 will be compound F. So chain isomer is the same molecular formula, same functional group. We only changed the longest chain. Now the longest chain here, it's a butane, which is 4 carbons. On this one is 4 carbons, but on this one it was 5. So it's a chain isomer. So let's check the IUPAC name of compound G. So let's check compound G. What is happening at compound G? So we have Cl, we have a methyl, we have a Cl. So we can start naming from left to right, or we can name from right to left. Our first substituent is at number 2 if we go this way. Even if we go that way, our first substituent is at number 2. And remember, the methyl and the chloride, bromine, iodine, they carry the same preference. So you can't say you're gonna prefer the methyl over the chloro group. They have the same preference. Okay, so it means now let's check the longest chain. 1, 2, 3, 4, 5, 6. So we know that our longest chain is 6 carbons. That means we have a hexane, since we only have single bonds. So this is an alkane hexane. So let's check our substituents. Okay, let me write it this side. 2.2.4 longest chain hexane, ane for alkane. So substituents, we have at number 2, and we also have a chloride at number 1, 2, 3, 4. So no, 1, 2, 3, 4, 5. So it's 2,5 dichloro. Then you check at number 3, you have a 3 methyl. So your name is 2,5 dichloro 3 methyl hexane in alphabetical order. Okay, and then the general formula of the homologal series to which compound E belongs to. So this one, they're just asking you to write down the formula of the functional group of E. So let's check the functional group for E. So compound E, I already did the structure and I said it's ethene, so that is an alkene. So the molecular the general formula for alkenes is CnH2n. This is basic stuff that you must already know by now. Okay, definition, I'm gonna leave that for you. And then let's look at compound A. We must write down the homologous series for compound A. So let's go to A. You see how nice it is when you get to the table and you write down all the information. Now you just flow because all the information is written down already. So compound A is ethanoic acid. So that tells you this is a carboxylic acid. Okay. So when they say homologous series, they're talking about the functional group. Okay. So the structural formula of its functional isome. So we must draw the structure of the functional isome of compound A. So now you must remind yourself, what is the functional isome of compound A? It means it has the same molecular formula but different functional groups. So you must now remember the relationship. You must now remember the functional group, which is a functional isomer of carboxylic acid. So carboxylic acids and esters are functional isomers. That you must know by now. So it means from this compound C double bond OH, you must now draw an ester from this compound. So you must form a functional isomer. So you already know it's gonna become an ester because esters are functional isomers of carboxylic acid. So now you just need to remind yourself, how does an ester look like? In the middle, I have an oxygen bonded to carbons. So since I only have 2 carbons, I have no other options. So I can simply say this is my carboxylic group. So the double bond O will be on that one. And then I have H. And then this side, I only have the hydrogens. So let's confirm by counting the number of hydrogens and carbons on both sides. So this one is an ester. This is the functional isomer of carboxylic acid. It's an ester, and the name is methyl for 1 carbon. Okay, remember this part is from the carboxylic acid, and that's what gets the suffix. So it's gonna be methyl 8. So let's check, do I have the same number of carbons? 1. Okay, let's start with hydrogens. 1, 2, 3, 4. Let's go to the other one. 1, 2, 3, 4. Same number of carbons? Yes, I have 1, 2, 1, 2. So these are functional isomers. You have the same formula but different structure. Okay. And then compound D undergoes dehydration. Write down the IUPAC name of compound D. We already did it. The IUPAC name is ethanol. Okay. The letter that represents a product of this reaction. So let's see. It undergoes dehydration. So let's draw the molecule. It's C. So this is 2.5.2. The molecule is C. This is compound D. If it undergoes dehydration, it means we are removing water. So that's what you must always remind yourself of these terms: dehydration, removal of water. So I'm going to put the OH here. Okay, so we're removing water. You know, when you remove something completely, you're going to be left with less number of bonds, which will result in a double bond. So let's see which compound is this one. Letter that represents a compound, a product of this reaction. So let's check which one is it. So it's going to be compound E. We already worked it out. So compound E. Okay, name or formula of the inorganic reactants that is used. You must now remind yourself what are the other reactants in an elimination reaction. We use a concentrated NaOH. We use a base for the removal. Okay, so that's what you must remind yourself. So in the next in the next video, I'm going to do another example, still from the same paper, but I'm going to do question 4 from 2021 past paper.